The hanging wall, the overlying side of a fort, or the wall, or rock at the upper side of an inclined beam. So let's read the fourth wall. After that, you go back to the picture and then look at it. The overlying side of a fort, or the wall, or a rock at the upper side of an inclined vein. So if there is an inclined vein, the upper side of that inclined vein is simply the hanging wall. So let's say we have the drawing is becoming too much, but please forgive me. That is what's an inclined. Let's say the all is inclined. This section, the overlying side of the fort or the wall or the rock at the upper side of an inclined vein. So this section can be the hanging wall, while this section can be the footwall. When we are doing the surface mining systems, I'm going to explain this very well with the diagram. It's difficult for me to do that here. So let's hold on with this while we get there. Now the footwall, the mass of a rock below a fault plane. So it's used the opposite way. You get it. We have hanging wall and then we have footwall. Hanging wall and footwall. Normally we put if you are designing your mine, you put your road in the footwall. Put your road in the footwall. Some always the footwall is competent than the hanging wall. To design a pit, if you're mine planner here and you're designing a pit, you put your road in the footwall. Now we talk about the shafts, as I said. Shafts, a vertical or inclined excavation in a mine, extending downwards from the surface or from some interior point as a principal opening through which the mine is exploited. The shaft in a this is an underground term, shaft. That's why I said this time around, most of them are just changing from using the shaft system to the incline system, because if you're using the shaft system, you can't use vehicles. You just have to use a cage. You put the materials in the cage, and then you hoist it up. But if you're using an inclined or declined, sorry, if you're using a declined, it's just like a road. I don't know. The circles, which ones are better when you once you are going down, you meet water. And then if you don't control the water, the whole pit will be flooded. So what we do is that we create on every level, or even in surface, at every point where we are mining, we create a sump to temporarily take water. You pump water to a sump. The word is temporal. Then after that, you do secondary pumping. That is pumping the water from the sump outside the mine. That is what we call a sump. So the moment you hear sump, it means that it's an excavation or a yamana just to collect water temporarily. So when the sumps are full, we pump water from the sump to outside the mine so that the place will be dry for us to carry on our mining activities. And then we also talk about stope, an excavation from which ore has been extracted. That is what I explained using the diagram. No? Yeah. As I said, let's say this is our incline, our decline. We have our cross cuts or access. We have our drift here. Let's say we have the ore lying this way. So we have going to mine this ore. So when we drill and then we blast, we drill, we blast. There's excavation that it creates. It's what you call the stope. The stope. So we draw another one here. We create another stope here. So stopes are excavation from which ore has been drawn from. Intiana emua, emua, a tray, just 10 emua. Papa and fire 3 meters, then you draw, you take your ore, you go away, then you prepare the next phase, you drill, you charge, you blast, you get the ore, till you go. The underground mine I visited, I think na stope biano, the length was it 30 meters? Yes, 30 meters. It's 30 meters in, 30 meters in. So let's say this is the entrance, 30 meters inside, 30 meters inside. So then you draw all in the free. So a stoop is an excavation from which ore has been drawn. You all in free more. Rebecca stoops. Stoops. Nti you all the free massa finite that one. It depends on the underground method you are using. Some of the underground methods will require you to fill the stoop, fill it back for stability purpose so that the ore wouldn't break. All right. A gang. A gang. This term is normally used by the metallurgical engineers. It's the worthless mineral, those associated with the valuable minerals. Now, yesterday I told you when I was defining the mineral that although let's say you are looking for gold deposits, but you can mine and then you bring out gold, all right, but not other mineral, can gold, no, in their very small quantity. That is not the mineral of interest. That is not what you are looking for. You are interested in gold. Now, sa other minerals na ibe ka ka ho ni na yem penny na no. That minerals na your friend gang. This is not used by the mining engineers, mostly used by the metallurgical engineers. Now, so someone will ask, what's the difference between a gang and then a waste? A gang and the waste. Since we are not considering the gang to be part of the mineral of interest. Now, the waste is the barren rock in a mine. So there is a little difference. The little difference is that once it is in the pit, it is waste. But if it finds its way in the metallurgical department or the processing plant, we call it gang. Waste media she if you don't like it, 0.000 grade. But then we can take a medium or medium high grade. It means that your associations of other minerals are getting in contact with the ore. Do you get it? We have other minerals that got in contact with the ore. But then let's say we blast, you've gotten ore, we want to go and then we want to take it to the milling plant, mill it, and then take the gold deposit out. But after we took it to the lab, we got to know that not only ore, not only gold ore, we saw copper in a very small quantity. So that copper becomes a gang. But if it's the pit, oh, you waste rock, it goes to the waste dam. And I also talk about the country or the host rock. The rock in which the ore is enclosed. I think I've explained this. The country or host rock, the rock in which the ore is what? Enclosed. It's yesterday I told you that the ore is being embedded in a rock. So the rock, that particular rock, that's the ore or the mineral of interest is being embedded in. That is what we call the country rock or the host rock. Normally, it is the type of rock around that particular area. Stockpile is a combination of subgrade or methodologically different ore. That's although sedum formally scheduled. Now, let me bring it down for us to understand. A stockpile. Let's say we are mining. We as you are mining, we meet high grade, we meet low grade, we meet medium grade, high, and those things. Per our schedules, we are meeting high grades. In a high grade, we are mining. It means that we don't need the medium grade for now. Now, if you don't need medium grade as we are mining right now, the place that you go and store the medium grade, that is what we call the stockpile. Bedding. For this, it's normally this under blasting. All these terminologies. Okay, the first two is under blasting. Bedding. Okay, so let's tackle bedding. If there is, you see, we are drilling. Let's say this is our drill pattern. We are saying that the distance from a charge measured perpendicular to the nearest free face or open face, that is bedding. Now, this is our blast hole. Yes, the distance between this blast hole and this blast hole is what we call bedding. Yes. So you can say that the distance between two blast holes on the same column is what we call bedding. But then if you look at the distance between this and this is what we call spacing. So it is bedding and spacing. So if there's a distance between this blast hole and this blast hole, this distance we call it bedding, this distance we call it spacing. So you can go to your mind and they will say, oh, the bedding to bedding, we are going to fire. And then the design for the design of this particular blast, the bedding is 3.5, the spacing is also 3.5. It means that from one hole to another, on the same column, the space between them should be 1.5. The space between this and the other hole vertically should also be 1.5. Yes, it depends on the design. Then we have this pattern. We have the square pattern where we have holes. Okay, so we get to blast designs. Okay, we also talk about that. So I think let me move on. We have boulder. Yes, boulder. This is common term in mining. Yes, anyone to explain? Boulder. Now, boulders. Every company has what we call the fragment size. You were to blast via your sizes cry yeah expected. We have sizes that we are expecting. Now, if you don't think about that, now blasting we are over blasting, blasting is the most expensive aspect in the whole mining process. Now we know the size that we are expecting, or the size should fall between this and that particular range. Now, how do we select the size that we are expecting? You select the size based on your crusher size, the feed, your crusher on the size. Now, what size when they meet me upper? If it can take, let's say, 2, it means that you are blasting should the size that the blast that you are blasting is the size that you are supposed to feed the crusher should be between, let's say, 1 to, let's say, 1.8. Anything above 2, you call it boulder. It's blasting. Yeah, designer now. They'll be design. My plan will be designing blasting in himself. Fine. This is what the company requires. So then I should design a blast in such a way that I will not get boulders. If you get boulders, it has a lot of effects. The stones are too big. We can't pick. Sometimes it's me like a siama. Yes, fire beam. Tomorrow I'll plan and show you a video. I have a video on that. Sometimes you blast, you get a very big rock. It's me boulder back on the down track back. Now I am a fashion to move in. If it is waste, they are fine. We take it and go and do it away. But if it is all, if you don't take care, they will sack you. If it is all, it means that they have to drill the boulder again and fire it to get the preferable size. So that is why it is very important as mining engineers that you know the size of the blast before the shot. And that happens to be the research work I am working on very soon. The report will be out. Yes, I am going to use AI techniques to predict the size of a blast. So in my models, you even see the sizes before you blast. So these are expected sizes that we need. Let's look at some of the factors that causes boulders because it's a very serious issue. Now, the bedding to spacing ratio. If you increase the bedding to spacing ratio, sometimes you get boulders. If you don't put in enough explosives, you get boulders. If there are leakages means that you find say a bona one drip pattern I drill at one. Cracks it will mean to pump explosives in the room. Most explosives in them cracks in the neck. So I visited a certain mine, I think Goldfields, and then they were using something called blast sleeves. Before they pump the explosives into the hole, they pump tube no set rubber bimusa and some that she hold to pump here and cut about a rubber dimension before we do our stemming and then finally we fire to get the size.